Hi there, I'm Brian here for the Lincolnwood Library today to go in more depth on Microsoft Excel, specifically creating formulas. In the description of this video, there is a link to our file that I'm going to be using, and it's called Lincolnwood Library Excel Formulas. So from my desktop, I'll double click that and open it up. So you see at the bottom there are a whole bunch of tabs for our different exercises. You can click the YouTube logo to go to the Lincolnwood Library YouTube page, and you can see links to all of our previous archived Microsoft Excel classes. Beginning Excel, the absolute basics, intermediate, going a little more in depth, and our class focusing on data tools like pivot tables. And you can also see all of our technology classes in that playlist. And you can click the Lincolnwood Library logo to go to our website, lincolnwoodlibrary.org. So today we are focusing on creating formulas. With careful applications and combinations of formulas, you can go from basic data analysis to powerful data processing and manipulation. Each formula you add to your knowledge allows you to harness more of Excel's power, and you can use that power on your data. Excel is as flexible as you are creative. So today in our Microsoft Excel Creating Formulas class, we'll attempt to add a ton of formulas to your repertoire, including ones for basic math like sum, average, mean, median, mode, rounding formulas, applied math formulas where there are some kind of variables, COUNTIF, SUMIF, logical formulas, if, and, or, and not, just like basic computer science, formulas for dealing with text like Concatenate, and a whole bunch of formulas to help clean up and reformat text. Some formulas related to dates and also index and match. We'll also do some things with references as well. On this first tab, we have links to all of the tabs as well. So I can click this one and it takes me right to our first exercise. And we have links in the upper right of each specific tab. I can go back to the index or to the next exercise. I'll go back. And our examples are going to be first the insert function menu, then we'll do rounding, counting in math with a large data set, relative references and absolute references, along with table references, cross worksheet references, and cross workbook references we'll touch on briefly. We'll do a brief exercise on array entered formulas as well. We'll cover if, and, or not formulas for logical operation. We'll combine text with concatenation, and then we'll do more with text, formatting it and fixing it. We'll do a little bit about dates and index match, and then a conclusion with an exercise where you can think about writing your own formula. I call it pseudocoding because I think that writing Excel formulas is basic programming, but some people disagree. So thanks for joining me for this class, and we'll get started. I'll go to the introduction worksheet. So each of these examples, at the top, we have a task that we are given to kind of ground this example in the real world. And then techniques you'll use, how you can use or pair what you learn in the exercise with other aspects of Excel, and kind of why we're doing this. So we've got some products and days ordered and days received by customers, and a list of days off in this example. We want to figure out how many days it took to deliver minus the holidays. And right now I don't have any idea what formula I need to use. So we can first click into the cell where we want our formula to appear, delivery time, in cell G10. Now you can search for formulas online. You can Google things. There are lots of resources for Excel help, but sometimes you don't want to leave Excel itself. You can click into the FX Insert Function menu to browse through all of the functions that are available. So I could do a search in here. Maybe I know that I'm doing something related to dates, and it pulls up some formulas. You can click on a formula, and beneath it, it is described. The description omits the equal sign that you always have to have before you start formulas, but it gives you the name of the formula, parenthesis, and then the data, the arguments or attributes that it requires. And it gives you a little text description. Now this is not what we need, so I'm going to have to look more. You can also browse by category. So maybe I want to look at text formulas just for a second as an example. I can take a look at the replace formula. But I can browse to a section that I'm pretty sure is actually relevant in this example, date and time. So I can just browse through these, read some of these descriptions. It's not related to the specific time, so I don't need hour or month. But let's look at network days. So it takes a start date and end date. We have both of those. And holidays. So it returns the number of whole work days between two dates. That sounds good. So using the insert function menu, if I hit OK, it also helps me build the formula, which is great. So you see it started typing in the formula bar, but I'm going to fill it in this function arguments menu. So I'll actually move this off to the side because I need to select the data. Anytime you see this icon in Microsoft Excel, it is expecting you to click on data in the spreadsheet. You don't want to use the arrow keys on your keyboard. After doing that, it will move to a different cell after you've clicked the cell. So I can click on this little button and click on my day ordered. Move my menu, click this button again to reveal the rest of the function arguments menu. I can click into end date, and you see as I move through these text entry boxes, the particular variable or argument or attribute that I am working on is described beneath. So end date is a serial date number that represents the end date. A lot of these descriptions are not very good, but they are definitely better than nothing. These are written by engineers who have to do very logical work that is formulaic and always works the same consistently. So a lot of times you kind of have to learn a little bit, but that's what we're here for today. So I'll click this button next to end date and click on that date received. Click the button again. Now the holidays. It's an optional set of one or more serial date numbers to exclude from the working calendar, such as state and federal holidays and floating holidays. So yep, that's exactly what we need. We can hit that arrow, select those days off. Click the down arrow. Now this list is not going to move. If we drag the formula, these values would change right now. So if I click here, I can add dollar signs before the I, and before the 10, and before the I, and before the 13. to make sure that this list will not move if we drag the formula later. We'll talk more about references in a bit. So I think I filled everything out. We'll hit OK. And it formatted it as a date. Let me just format it as a general number. And there we go. Now I can click into this formula, and using its lower right corner fill handle, that little tiny green dot, when my mouse is a thin black plus over top it, I can drag to apply that formula to the rest of the cells. And you see that the reference to the holidays stays the same, but the row numbers for the rest change. So you can use the FX menu right next to the formula bar to browse through formulas, and it will help you to construct them as well. I'm going to go to the next exercise on rounding. So oftentimes as you construct formulas, you may divide something or have a number come up with decimal places that you weren't expecting. Or in this case with products, you may have that extra third decimal like gas stations have that most places don't actually use. So it's a pretty common task to round things. And there are 4 formulas that you can use for rounding. Round up, round down, ceiling, and floor. And you can use these with just about any math that you do, any kind of formatting, currency, and of course, you really need these if you're looking to deliver kind of clean math results. So I'll go to round up. Again, all formulas start with equal, and then you call the name of the formula, round up. And as you're typing, you see the formula options that are available. You can kind of browse those, and you might see one that helps you, and you can see the little description. So round up, Shift 9, open parenthesis, and again we get these arguments, these parameters that are required, the data that the formula needs to function. So it needs a number and then how many digits to round to. Perfect. So I can use B, that's cell 10, comma, and then the number of digits. So it's got 3 decimal points right now. I really only want 2. Close parenthesis, Shift 0, enter. And there we go. Now you see it's still displaying that third 0. I need to change the formatting, but it has rounded it, and it rounded up. So I could do the same thing for round down, just type the different formula name. Still the same reference to that cell B10 and 2 digits with the comma in between each parameter. You have to make sure after you've entered one of the variables that a formula requires to put your comma in. So we want 2 decimals, close the parenthesis, and there we go. Now you see it even rounded this one down to nothing. Now ceiling and floor are slightly different. They allow you to define your own point to kind of round to. So you can say to the nearest 5 or the nearest 10, and the ceiling will go up and floor will go down. So equals ceiling and the number. And again, this kind of point of significance. I had examples described down beneath the nearest 5 or the nearest 10. So let's do the nearest 5 cents. So 0.05. Close parenthesis, enter. So you see it is rounding up to that nearest 5 cents. Now we can do the same thing for floor. And the number B10, and the significance we're going to do 0.10. And there you go. That rounded down to that description of significance that I entered into the formula. So next, we'll go to our counting and math. This is a data set of some real but anonymized with fake names and places data from a shipping company. And they've got when orders were placed and charges. We're going to focus on the charges and the account type and carrier. So we can do all sorts of math automatically in Excel. We want to kind of process this data. Our task is to generate a whole bunch of different statistics about it for someone else. So we can use a ton of formulas. We'll go through all of these. We've got the formula name in column J, and then beneath kind of what it does, the cell beneath that will enter the formula. And a couple times there are multiple different ways to do the same thing. So depending on what you're doing, it might be good to know multiple ways to do it in case there's a problem and one doesn't work, another one might work. So first we want to total up all of the charges. So equals sum, open parenthesis, and all of the numbers. So that is from H10 through H107. And close parenthesis, enter. So there we go. Now we can do average as well. So equals average, H10 through H107. Now when you're typing references, you can do either uppercase or lowercase letters for the column letter label. I did uppercase for the sum, I just did lowercase for average. Kind of the lazier way of constructing a reference, but it might be faster, it might be easier for you. And of course, between the first cell and the last cell of a reference, you need the colon, which is the shift and then the character to the right of your L key on your keyboard. Close parenthesis, enter. That is the average order price. So the most often occurring mode, so equals mode, that same range, close parenthesis, there you go, several orders of $790. You can do median as well. And a lot of times formulas take multiple numbers. You see in the description, number 1, number 2, ... But you can also just give them ranges of numbers. So H10 through H107 again. And the median order is higher. Now with min, you can calculate the minimum number in a range. So equals min, open parenthesis, that same range. Close parenthesis, enter. Now there is a similar formula called small. Minimum finds the smallest number in a range or list of numbers automatically. Small adds an extra parameter to allow you to say, I want the second smallest, I want the fourth smallest, I want the seventh smallest. It's arbitrary, whatever you want. So equals small, open parenthesis. We need the set of numbers, so H10 through H107, comma, and then say for the smallest, we have to do the first smallest, 1. It's a little confusing. So close parenthesis, enter, and it gives us the same value. Max and large are the same as min and small, except instead of doing the small side, they do the large side. So max, H10 through H107, close parenthesis, enter. There we go. Equals large, open parenthesis, H10 through H107. And we need the first largest, the biggest. Close parenthesis, enter. It's the same number. So we can practice that small formula more with this example, small, that same number set, and a 2 for the second smallest. So whatever number you're looking for. And apparently there are a couple orders with 677. So maybe I can increase this to, say, the 7th smallest. And there we go. It's that same number as the mode again. So for large, it's asking for the 14th largest. So that 14 number as that K value. And there we go. Now, everything we have done so far is kind of a fixed strategy where we've manually put in values, except for the holidays in the insert function, because those holidays didn't move. But these other formulas we've just entered in, second or first or fourth. You can make a formula modular by calling a reference to another cell. So we can arbitrarily say the xth largest order in a formula that we'll put in cell K35. And we won't have to change the formula if we just change the number in this cell K34. So maybe say I want the 43rd largest, and the formula equals large, open parenthesis, same number range, H10 through H107. Now, instead of just typing a number in, like I've done for all of the min, max, large, and small formulas, and also for the ceiling and floor formulas before, I can just call this cell K34. I can put it into the formula. Close parenthesis, enter, and there we go. Now, maybe I want the 50th largest. I can just change that on the fly without updating the formula. Formulas automatically recalculate anytime the data they refer to, they call, changes. All right, now we can get to some more difficult and complex formulas. Counting different cells is a task that is often done. If you've got logs of data and need to count how many times a certain type of text appears, COUNTIF is a really popular formula that you can use for that. So it starts with equals and COUNTIF, open parenthesis. So we want to know the number of orders with the house account type. So this shipping company shipped to kind of multiple different types of locations, and house and big box. So first we have to do the range that we are going to count in. So that's D10 through D107. And then the criteria. Now it doesn't tell you this here, but your criteria, if you're just doing text, have to be in quotes. So shift the key 2 to the right of L, and then I'll type house in all uppercase. Another double quote and close parenthesis. Enter. So there were 65 orders in this small data set sent to houses. Now you might notice that there are some blanks in this data. A lot of times databases spit out bad data, even though the databases are usually pretty carefully set up. Sometimes things fail. We can count the number of correctly filled account types using the formula COUNT A. In a range, it tells you how many of the cells are filled. So equals COUNT A. And again, it counts the number of cells in a range that are not empty, aka are filled. Open parenthesis. And that range is D10 through D107. Close parenthesis, enter. So 84 of them are filled with either house or big box. I can use count blank to basically do the opposite. Count blank. Except this time I want to do the carriers, which is in column E. So the range is E10 through E107. Close parenthesis, enter. So there are 17 that are blank in this range. Now, even more complex, we can kind of put what we've done here together. You can add numbers rather than just counting how many there are, but add the actual values in cells if they meet a certain criteria. So we want to figure out the amount charged when the carrier isn't known. So the carrier is the value in column E in this example. So we'll do equals SUMIF. So let's look at the parameters here. So first it takes the range, and it's tricky because there's two ranges in here, range and sum range. The first range is the range related to the criteria, kind of the if condition. So that is E10 through E107, our carriers. Then the criteria, so double quote. And this is a hack where the carrier isn't known. You can say kind of nothing in Excel with double quotes twice. So 1, 2, that kind of means the absence of data in Microsoft Excel. So that means basically blank, and we'll pull up the ones that are not filled. So comma after that, and then the range that I want to add after the blank. So that's H10 through H107. Close parenthesis, enter. So almost 30,000 bucks of orders where the carrier is blank. Finally, you can have more than one of those conditions in a formula, and that is with SUMIFs. So equals SUMIFs with that S plural at the end, open parenthesis. Now, this formula is kind of totally backwards. So first, it requires the range that you're going to add. So that's H10 through H107 in our example. Then it asks for the first criteria range and the criteria, and then the second criteria range and the second criteria. And it's arbitrary. You can do as many of these as you'd like. So our first criteria is the house orders. So we're looking in column D, the type of account. So D10 through D107. Then the criteria, house, in double quotes on either side. Now, we only want the house orders that were shipped by America Broker, like this example in row 40. We want to make sure that is added up. So the shippers are in the next column, column E, E10 through E107. And then we give double quote America Broker. And give it a close parenthesis and enter. And there you go. It's a smaller set of the charges. So you can do a ton of different math. We showed you sum and average, mode, small and large. We showed you modular design, where you can put variables somewhere to be changed on the fly, and then your actual math doesn't have to be updated. And you can use blanks to refer to the absence of data in formulas that try to find things. And you can use these with basically any other Excel formulas, but concatenate and logical formulas are ones that you're likely to use these with. So let's go to the next exercise. We're going to talk about relative references, and we'll go through all the types of references. So relative references mean if you put a formula in and then you move it somewhere else, aspects of the formula may change. If you move the formula down, the row number will change. If you move it right or left, the column letter will change. You want to be very aware of this as you're putting together your data and you're moving things around. You would use this with kind of any counting formulas like we were doing in the previous example. And of course, large data sets, you want to make sure you calculate things correctly. Relative references are really flexible, but sometimes you don't need flexibility, so it's important to pay attention. So in this example, we have some employees who have a wage and they've worked a certain number of hours in week 1. And this doesn't even require a formal formula to calculate. We'll just do an equal sign, B11, shift 8 for a multiplication symbol, and then C11 for the number of hours. Enter. Click back on that cell. Now, if I go to the fill handle, that green dot in the lower right corner, and when I have that black plus, drag down, I can do that same math for all the rest of these people. And when I scroll through it, looking in the formula bar for each one, I see the B and the C stay the same because this data is still for all of the employees in the same column, but the row number changes because I moved down. So that is perfect. Now I set this up for week 1, but I can copy it, go to week 2, paste it, and it figures out the same math. Now it stayed in the same row number because I just moved left and right. I moved right over about 5 cells. And it figured out that I still wanted the 2 columns directly to the left of the current cell that I'm in, I11. So I can click in that and drag that down again, and it does a whole bunch of math for me. So your relative values will adjust for you if you move them up and down or left and right. And it's really important to be aware of that as you are writing your own formulas. Now, absolute references are the exact opposite. And we have an example where we've got some products and their price, and then we need to do a price with sales tax. It's really important to be accurate for something like this. The sales tax value is modular. We've got it set up here as a variable that we can change in a different cell. But when we're doing these calculations, of course, we have to remember that the modular value is not moving. So I can click into cell C13 and write up this formula. And this is just math. It's not exactly a formal formula. Equals that cell next to it, B13, plus, and then I'm going to do a parenthesis, B13 times, then I need that sales tax value. To make the value an absolute value that will not move when I move the formula, I copy, paste it, or drag it, I have to put dollar signs before the column letter and the row number. So dollar sign B, dollar sign that's in 10. And you can, on the fly, see that your references are correct by looking at the cells being highlighted in Excel. So close parenthesis, enter. And I set this up as a table, which we'll talk about later, so it automatically put the rest of the formulas in for me. And when you look in the formula bar, you see that they all refer to B10. They don't have any errors. But the rows update for the other 2 values where we need the price. So now, of course, we can also copy-paste these formulas. So I've got this price with sales tax, and companies thinking about expanding into another product group. They're still working on it, but they've got one price, and if I paste that value, it calculates that as well. It changes to refer to the new product because that value, the F13, which is in this data twice, is totally relative, but the B10 value is absolute. Now you can do combinations of relative and absolute. You could put a $ only before the column letter, or a $ only by the row number as well. You can mix things up like that to make your references what you need. So let's go to table references next. Tables are really cool feature in Excel. They add extra types of references when you enable them. This is a feature that I have not seen in any other spreadsheet program. It's very unique to Excel. You can refer to whole rows of data rather than ranges like H10 through H107 like we talked about before, or you can refer to specific cells with a structured reference language that is based on the names that you give the columns at the top of your table. So it's important to name things well. And this is a standard formatting for a table. If you click into data in Excel and then you see a new menu appear, Table Tools Design, that tells you that you are in one of these formal tables. And in this menu, in the Properties group, you can see the name of the table. If you want to call this information outside of the table, like in our total charges calculation, you'll have to call the name of the table and then one of its rows or specific cells in a cell or a column. So we want to calculate for each row here how much less it is than the maximum order. So we'll click into cell F11 and start with our equal sign. First, we have to find the maximum charge. So we'll use the max formula, and then we want to refer to the whole range of charges in column E. To do that, you start with a bracket next to the P key, and it even lists for you all of the available columns that you have, and you see they match the labels that are in this spreadsheet. So I'll say charge, close bracket, and you see that refers to the whole data set, the whole column. I can scroll down and it goes all the way down. So close parenthesis, I found the max charge, and then minus, and I need to refer to the specific charge value that is in this row. And to do that, you do a bracket and then an @ sign, and then charge. Or you can just simply click on it, and it will figure that out for you. So hit enter, and there you go. Now there should be one that is 0 as the max. Here it is. So now we can also refer to values in the table outside of the table itself. So we want to find the total charges. We found this before a different way, but you can do it with table references too. So equals sum, and we have to say that we're going to go into the orders table and then the charges. And there you go. So that is how table references work. They're more structured, so you don't have to be worrying about ranges like E10 through E107 if things moved down one extra row here, even though it's the same data. It's really E11 through E108 and F. So that is how you use table references in Excel. Now, you can also refer to values that are in different worksheets. in this example, we've got a department that is keeping track of its data in this tab of this spreadsheet, and there's a different department that they want to compare to in a different worksheet. And I'll just go to that worksheet for a minute. Here is that other worksheet. Back to the cross worksheet tab. So we want to calculate that other department to see how these two departments are doing. And the way this reference works is that after the equal sign in the formula, when you want to call the value, you do an apostrophe, then the worksheet name, so in this example, other department, then another apostrophe, and then an exclamation point, and then the specific cell reference. And you can use the dollar signs to make these references fixed if necessary. So for our comparison, for this department that is already put in here, they are adding up all the months. So for the other department, we want to add up their sellers for their month. So we're in column B that data is in. So in this spreadsheet, to do that, we'll do equals and sum. Of course, we've used this before to add things up. And then we've got to go call those numbers. So again, to reference that other worksheet, we start with an apostrophe, then other department, apostrophe, exclamation point, and that data was in B3 through B5. Close parenthesis, enter. So there we go. Now this data is relative. There are no dollar signs by the B3 and B5. So I can drag this over and get all of those different calculations. And we see that the other department is doing better than our base department. So that is how you can use references like that. And if, for example, I had forgotten to do the total, you can also, after pressing an equal sign, just go find the data and click it. But I had forgotten to put a total here. So you can refer to a specific cell, and then obviously there's nothing there, and we can put in some totals. You can just highlight ranges as well, and then I'll drag that down. So then when I go back to the other worksheet, it automatically updated that. Now you can make references across workbooks as well. This is much more difficult, and I'm not going to actually demonstrate this, but we have this nice table of all of the possible references, except for those table references that we described in that other sheet. So we just covered referring to data in another worksheet within the same Excel workbook. But if it's in a different Excel file, .xlsx something else, not this one, this is how you refer to it. You basically have to call the full file path of that spreadsheet and then refer to the sheet and the specific cell within it. This can be a little inconsistent if you're on a work network drive. It can be tricky, but if you're just at home and you control everything about your computer, you can call in values from other totally different Excel files into your spreadsheet. Now let's go to array entered formulas. Array entered formulas are formulas that you kind of have to pass through the data twice. There's a table of value, and instead of doing things like in this example, yellow highlighted step 1 and step 2, you can do the same thing in a one-step method, except in that one step, it has to pass through the data twice. So you might imagine that a sum formula could work like the example in cell B21 equals sum. And then sum is always just adding numbers. So for each number separated by a comma, you could put a formula. For example, B8 through B16 multiplied by C8 colon C16. Close parenthesis, enter. It doesn't work. So when you get things with a green triangle in the upper left corner, and there are various different descriptors like this for error messages in Excel, when you click on the cell, it gives you that yellow caution sign and lets you know that this is an error. If you forget to use absolute values in a situation when Excel has determined you probably should have, it will give you errors. You can either ignore errors, or most of the time you'll want to click into the formula bar and correct them. And there's really not much correction actually required here. When you have an array entered formula, you enter it in, and then instead of just hitting enter when you're done with it, you hit Control-Shift-Enter, and then it works. And when you highlight that cell again, you see it adds the curly brackets around the formula to tell Excel that it has to pass through the data multiple times. So you always just hit Control-Shift-Enter when you're finalizing that formula. And anytime you're working with large data sets or lookups or match formulas, you might potentially need these. Anytime you're kind of doing something that you could do in 2 steps, in 1 step, it could be an array formula. Let's take a look at if, and, or, and not formulas next. So we have this same data set of shipping company information, and we want to kind of spruce it up with more information that we're being asked for. So you want to kind of fix data. And you can combine this with anything that's hard-coded, or if, COUNTIF is blank, and error finding formulas. You can use this to kind of change things around. You can simplify formulas. You can do advanced logic. So for our if formula example, we want to figure out if there are any errors in the account type and carrier. So we can start with an equal sign, and the formula is if. The if formula checks whether a condition is met and returns one value that we specify if it's true, and another value that we specify if that condition is false. So open parenthesis. Now we're going to introduce another formula here, is blank. And it spits out if a formula is blank, true, and if it's not, false. Is blank, and then we just have to say a cell. So we'll do the account type, close parenthesis on that. You can have formulas within formulas, and when you do a formula within a formula, it's kind of tricky, but you don't have to do the equal sign. It's the only time when you don't have to do an equal sign. Only the first equal sign when you are putting your formula together. So if cell E10 is blank, then we want to say that there's an error that needs to be corrected by someone. Otherwise, and you could do multiple ifs within each other, if, and we're going to do another, is blank, that next cell, F10, so if that one's blank, we also want to say error. Otherwise, if neither of those conditions are true, we want to say that the data is good. Close parenthesis. Now, it kind of moved the tooltip back because we put the two if formulas inside of kind of each other, we have to do 2 parentheses to close up this formula. And if I only did 1, it would give me an error that I forgot to basically close the last parenthesis. So I'll click into this formula, close parenthesis, enter. And there you go. It just automatically did that for us. So now AND can help us figure out if kind of 2 conditions are true. So equals AND. Now, rather than a formula defining our condition, we can also just kind of put in some basic math into the conditional. So if cell E10 equals house, then we're going to do another one. And if F10 equals Lincolnwood rail. So now this is a case where you do have an extra equal sign. It's just saying that the cell equals a value. And we'll close parentheses. So it's going to evaluate both of these conditions. And if it's true, it'll spit out true. So this is going to be pretty rare, but here is one example. They shipped to a house with Lincolnwood Rail Company. Go up to the top. So for OR, only one of the conditions has to be true. So equals OR. So first we're going to do F10 if that equals Rex Rail. And for the state, if it is being shipped to Florida. Close parenthesis. And I was actually mistaken. It's true when either of the conditions are true. But there are a lot of cases where neither of them are, so it returns false. And then finally, not is, in my opinion, a little confusing. It basically returns the opposite. So we want to find out if the order is going to Canada or not. So equals not, and then the state value, H10, Canada. So it's not to Canada. It's not to Canada. Maybe we have to pay some sort of duty when we are being shipped to Canada. So false means that it was to Canada. And when we highlight the data, it turns that up. So you can use these formulas in combination with basically any other formula in Excel as you are parsing through your data. We'll go to the concatenate exercise next. Concatenate is kind of a funny word for joining things together. We'll use the formal version, concatenate. You can also just do what I think of as kind of a lazy concatenate on any formula with an and sign. You can do basic math inside of a concatenate. You can combine existing data. You can make labels. You can do all sorts of different things. I use it in making dashboards, doing statistics, labeling things. It's really flexible. So from the shipping company, they've got the year, month, and day in separate cells and formatted as text, even though the data is really a number. So I want to reformat that and fix it. I want to make it a number, and I want to make it in one cell. I've got all the data. I just need to join it together. So we start with an equal sign and concatenate, open parenthesis. So it just accepts as many items of text as I want to put into the concatenate formula. And it can be 1, 2, 3. It can be as many things as you want to put in. It can get confusing, and you can also nest other formulas as the quote-unquote text value, as long as the formula spits out some sort of text, whether it's a true or false like the logical formulas, or a number like SUMIF, or a count like COUNTIF. Whatever the formula spits out will be treated as text. So we can also just click on cell references. So I want to start with the month. And you see it's doing that table reference, but I can also just type in a reference as well. Between our items of text, we always do a comma to separate the attributes that are being taken by the formula. Now in a date value, you either have slashes or dashes between each of the parts. We can add arbitrary text with a double quote, and I just want a slash sign between the parts of the date. Comma before our next text value, then cell C10, comma. Now I need another slash, and finally the year number for these old orders. Close parenthesis, enter. So it reformats them properly as dates based on concatenating, combining the data together. Now you can also do the lazy concatenate. I made an example here to show how this works. So it is a formula, but it's just kind of written on the fly. And you start with an equal sign, and then you just put your value that you want in double quotes after the ampersand sign. So equals, I want the name if I'm putting together an address book, and then and, double quote, I just want a space between that and the next value. After the value, you also need another and. So then L11, and there we go, the reference worked. So and, double quote, space, I want to insert a space. Another and, then M11, and double quote, space, because I'm putting in that space. Then another and N11, and double quote, space, double quote, another and sign because we're still adding things to this concatenate, and finally the zip code 011. Enter, and there we go. So for something like this, it might be easier to use the formal concatenate formula. But if you had most of this data already combined together and just needed to add another aspect, maybe for example the zip plus 4, you could spit out the zip plus 4 with an extra and concatenate at the end. So I often use concatenate for this kind of function to format text, but there are also specific formulas that allow you to format text. Maybe you've got text data that is kind of formatted wrong and you want to reformat it. You can use it with, again, concatenate and date formulas if you've got multiple different pieces of data that you need to kind of reformat a different way. You can also define kind of your own custom formats. And Excel has a really helpful support article on this function that I'm actually going to click to. Because in text formulas, you call equals text and give it a number, and then you define the format that you want the number to be spit out in. And without some sort of reference, you have no idea how to define those formats. But this page here tells you how to specify the format that the text formula will use. You refer to months, days, years, hours, AM, PM, etc. So this is a really helpful help page. Close that, back here. So I have source numbers here that we'll refer to in column A, desired formats, and then an example. But let's try these ourselves. So we want the date in that format with an extra leading 0 if the month is before October. So equals text, then that value, cell A13, comma, to split up our attributes. And now we have to format this text, and the format goes in double quotes. And I want month, month, slash day, day, slash year, year. Close parenthesis, enter. There we go. Now I just want the month number. Equals text, A14, and the month number is just 1M. There we go. The month abbreviation equals text, A15, is month, 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 MMM. Close parenthesis, enter. There we go. Full month name is just 4 M's, so basically the same formula. 16. There we go. Day number is just 1D, so equals text, A17, D. And the day of the week equals text, A18, 4 Ds. There we go. Year number 0 through 100 equals text, A19. And we need YY. We're not using that third value. The full year equals text, A20. 4 Ys. Enter. Time is a little tricky. Let's look at this formula. So again, you have to specify hour, minute, AM, PM. The format of AM, PM is totally up to you, but you have to specify it. So equals text from A21 and the format. So I want it hour, hour, colon, minute, minute, space. I want AM, PM. Except I want it in uppercase. There we go. Now, similar one in this example, A22. So the format, I want the dot, dot between. So this is a tricky one. Hour, hour, colon, minute, minute, space. So I want a period. I always screw this one up. I have to look at it. So the first slash is forward, A/P dot, because the dot applies to both of them, and then M. And there we go. You can also do things like output percents with decimal points. Excel doesn't do that by default really easily. So I'll refer to A23. And now I can do a number sign. And there we go. You can also do it for things that we don't exactly think of as like decimal numbers, a phone number. So equals text, value is A24, and we can just define our own format. So in our format, we want the area code with the parentheses, and then we're going to accept 3 numbers in those area codes, space, 3 more numbers, and then dash and 4 more numbers. So if you give it a 10-digit number, it will spit out the number in this format correctly. Now, you could also use this same formula if you're given data without the country code, and assuming it's all US numbers. You could add that in front without having to manually do it, which would be really tedious. So you just specify that one, open parenthesis, and then the rest of this formula is the same as the previous. So just like that, I added that, and if you imagine having a large list you needed to correct, this would be really helpful. So you can also, if you've got a list of plain text numbers, you can put dashes in a certain place, like for a social security number. So that value is A26. And then I've got to make my format. So it's going to accept 3 numbers, then a dash, then 2 numbers, a dash, then 4 numbers. Fractions are a little tricky. You've got the number sign for numbers. If it's a fraction, you use a question mark. So equals text, that reference, A27, then the value. So how many numbers? 1 number. Then question mark divided by question mark to show the fraction. And there we go. Now, if you're dealing with kind of business numbers, you need a particular format. You need leading zeros. You can do text and then the value, then the format. So you're predefining that everything's going to have 2 zeros at the front, and then you'll accept 4 numbers, and there it is. Same thing if you want to put text in front. If you're putting product names with some sort of arbitrary text before it. So corp, and then 4 numbers, and there you go. So you can use this to really quickly define formats. And I've used this before in reformatting calendar data for public libraries. And we put on a lot of events. It can be really helpful to be able to systematically reformat things in different scenarios. So on to fixing text. More reformatting just for kind of different uses. We're going to use these formulas listed here. And mainly you're fixing or reformatting data that isn't in the format you need it. So if you've got all caps, you can make it lowercase with the formula lower. So you just call that cell, close parenthesis, and there it is. We're not yelling anymore. Now you want to do the opposite. Maybe you've got a column label or something, and that's upper. So this quiet text, you grab that reference, and there you go. You can do sentence case with the formula proper. So this will capitalize each letter of the first letter of each word, but not the random capitalization in here. Now you can also format between numbers and Roman numerals. So 1 through infinity are referred to as Arabic numbers. So the formula is equals Arabic and then the Roman numeral. And Excel just thinks of VII entered into cell A11. It's just treating it as general text. But now it knows this is a number. You can count the number of characters in a string of text with the length formula, len. It only is going to work on text. So equals len, and then over, grab that reference, and it spits out the number of letters. If you're doing things like substituting or replacing text, you may have to algorithmically know how many characters are in words to properly reformat and fix them with other formulas. Now, sometimes you might get extra spaces in variables, and you can trim out the extra spaces with the trim formula. So equals trim, and then give it your text, and close that up. Finally, if you've got other bad characters, special characters, you can clean them out. So equals clean, and then our cell A14, we don't need that value in between. Now it's not going to replace it with a space. It's just going to remove it and kind of concatenate the data next to each other. So you may have to by some other means, add a space there if you needed it to. I like this example, kind of a bit of a joke here, but you can substitute text. If I can spell equals substitute, and we take some parameters here. So first, just like all these other formulas, the base text, then what we're looking for within the string. In this case, it's the whole string, but if you have a large set of text, you might only be looking to replace part of it. Then you want to tell the formula the new text to replace it with. And finally, if the source that you're substituting away from happens multiple times, which number time do you want to replace it? The first, the second, the third? I want to just replace it the first time. And there we go. Now here's another example. So the text we're starting with. And we just want to get rid of that extra AM in there. 9 to 11 AM, not 9 AM to 11 AM. It's kind of repetitive. So the old text we need to replace is space A dot M dot double quote, comma, the new text. Now remember, before, blank is just a double quote. And the instant number, the first. So there we go. It fixed that for us. Now you can also kind of reformat and add functionality to text if you want to put in a hyperlink. So equals hyperlink. And first, kind of backwards, the location, the web address that the hyperlink is going to go into is in cell A17, the Lincolnwood Library website. And then by friendly name, they mean like real text. In quotes, I'll say library website. And there we go. And these links work. If I click that, it will pull it up in a web browser. And you can see everything that's going on at the library. I'll close that and back to the spreadsheet. So that is fixing text with a variety of formulas. Next, let's take a look at some dates. You might have to manage information about dates for a company, for example, and you might need to find the difference between dates and different things. There are a lot of great formulas for doing this. We'll use some like today, weekday, year, e-date, and text. And of course, you can pair this with managing things in date format, addition and subtraction, all sorts of different things. So we'll start in column B. And if you've got a list of birthdays in a year, you might want to find the day of the week. And we can use the text formula for that. We can, within the text formula, do the weekday of the previous cell, which spits out that day. And then we want it in this format, the full day format. So there you go. You found that really quickly. Now, if you've got a higher date for these people with these birthdays, you might want to find the number of years at a company. So there is a year formula, and there is also a very special formula called today, which doesn't take any parameters. It just has an open parenthesis and then immediately close parenthesis, and that puts into the formula today's date. Excel is able to get that from the source computer, and it can put that into your formula. So we need an extra parenthesis around that. minus the year of the cell to the left. Close parenthesis, enter. And that looks right. Now you might also have to calculate the number of months accrued, and you could simply multiply the number of years by 12, but there may be situations where you're not finding the year first. So you could do equals date diff. And this is a situation where Excel supports a formula unofficially. This has been deprecated, but it is still a really useful formula. So cell C9, and then today, and we want it in month format. And there you go. Next, let's take a look at some new hires down here. So we've got their hire date, and their supervisor needs to know their 3-month review date. So there's a formula called eDate, which returns the date indicated by a number of months before or after the start date. So we call that cell to the left, and then we want 3 months after it. And it gets that date for us. So that's really helpful. Now if I scroll up here, some other useful date and time formulas. Equals now spits out a current time and day. So it gives you the hour as well, which is very helpful if you need the time. The day formula with a reference to a cell or a number spits out the day. And the month with a reference spits out the month number. Now one final example down here. If I click into a cell, I can see the formula exactly. A lot of organizations recognize their coworkers on their birthdays, and if you're a supervisor, you might want not to forget somebody's birthday. And the power of dates in Excel and a whole bunch of if formulas, you simply can query every date in this list against today, and then have a whole mess of close parentheses at the end, and determine that today is not any of these days in a subsequent year. So day and time formulas are very powerful, and you can use them to process your information. Let's look next at index and match. Index and match are kind of the more powerful versions of HLOOKUP and VLOOKUP that are also more flexible as well. They're kind of more modular. You can find things with them quickly in large data sets. And you can also find partial matches as well, which is very helpful. So I've got this table of orders of some different computer products. And in this example here, we want to find April DVD drive sale number. Now, this is not too large of a data set, and I can just find that quick. If you have a really large data set, you might want a formula to be able to spit that out, and you might not want your formula to be subject to human error. So in cell A11, we can calculate this using the index match technique. So equals index, and we have to give it an array, a set of cells. So that is going to be from D8 to H19. And you see now, when I hit comma, it tells me that I have to calculate the row next. So I'll do a match of the January through December months. So the lookup value is the month up here, April. We've got this as a modular design. And then where we are looking it up is C8. through C19. And comma, the match type, we need an exact match. There may be some situations where you don't need an exact match. Close parenthesis on that formula within a formula, comma. Now we have to match a column. So match, and the value, DVD drives, again, modular design. We can simply type a new value in cell A9, and this formula will automatically update. And we're looking for A9 in the range of D7 through H7, comma, and we're looking for an exact match. Close parenthesis, and close parenthesis on the whole thing. And there we go. So 4,565, let's see if that matches. DVD drives in April. It does. So let's do flash drives in the same month. 1,108. Yep. So you can use this really quickly to look up certain data in a very large spreadsheet. I've worked with spreadsheets that have had thousands, even up to hundreds of thousands of rows and many columns. It's important to be able to match things and find them really quickly. You may not even know exactly where they are really going to be, like we do in this case. So another thing you can use index and match for is a hack. We've got, for our next example, a whole bunch of fake social security numbers, and they are in column L here, and you see the last value is 490711782. Hopefully that isn't your social security number. I just generated it randomly. Now you see we've got that up here. In column labels or other formulas, you may need to find the last value in a column. With index and match, you can do this really easily. So you call an index, then the column label, L through L. L:L refers to all the way down for column L, and then match. And this is a funny number. It's both numbers and letter. 9.9, a whole bunch of nines. E plus 307 is the largest number that Excel is capable of handling in scientific notation. So basically find the last row in that column, and we're going to do a less than match. And it spits out that last value. So we've got one more index match example. Now I pulled some of the social security numbers from this table here, and maybe the government messaged an HR person in a company, these social security numbers were exposed, or maybe a vendor, a billing company sent you that these numbers were exposed in a hack, and you have to match up the number to the name, and you don't want to just manually do it. We can do this with index and match with a little different strategy. So equals index, and now our array this time is a fixed array, partially fixed. We're going to do J $8 through J $37. So those are all of the potential social security numbers that we have to search through. Now we need to match the one to the left of this in cell N8. So we'll do match N8 in that same range. But in the other column. And it needs to be an exact match. Close parenthesis and enter. And there we go. It spits out who was exposed. So you can tell these people if they need to get some extra security. So that's how you can use index match. You can use it as a hack to find the last value in a column. This is something I have used very frequently. You can use it to look up data if you can imagine a very large data set, and you can use it to kind of match and spit out things. Finally, let's take a look at the last tab here, pseudocoding, for an example that will kind of wrap up most everything that we've covered today. So in this table here, there are amounts spent per month. And with this, you want to help people keep track of their expenditures as the year goes on. How much they're under or beneath spending, how much they have left to. So as some clues, you may use if or sum, maybe concatenate, you might round. We don't want anything hard-coded. We want this to be modular. And we may also want to take a look at Excel error messages, if there are any. So again, some things we might use, and we might also use mathematical operators. We haven't covered all of them so far. We have a table of Excel's mathematical operators down here. Minus, shift 8 multiplication, caret sign, shift 6, plus, less than or equal to, does not equal, equal, greater than, or equal to. So now pseudocoding is kind of a fancy computer science word for a very basic concept. Before we try to write some code, we're going to kind of plan out what we intend to do, what we plan to write. So pseudocoding is basically writing computer code, or in this case, Excel formula code, in plain English. But plain English kind of with the angle of using it for computer code. We have these amounts spent in a certain month, and you see that the months have helpfully been labeled for us. So before we start trying to write this code, let's try to plan it out. So I think this is probably going to be an if formula. So if adding up the values in column B, but I'm going to have to figure out how to start with only the first value and then over time increment to include them all. Is less than how much we should have spent so far. I think we might be able to figure that out with the month numbers. Then we want to do that amount that should have been spent so far multiplied by which month it is. Otherwise, add up the expenditures and say how much we're over by. So that's what I'm looking to do. Let's see if we can do it. Oops. Okay, so first thing, I'm pretty sure this is an if. So we need a logical test. So we want to test if the amount we've spent so far is greater than what we should have spent. But we don't want to write this formula multiple times. We want one formula to apply to all of this. So we're going to add up from B 14. But we don't want that value to ever not be included. So that's why I made it a fixed value. And if I click into my formula and use my F4 key, I can toggle between all the different versions of relative and fixed values. So B14, now here's a hack through B14. But this second B14 I made entirely relative. So if the formula is dragged down, it will expand. It will be B15 and B16 all the way through B25 as I need it to be. So if that amount adds up to be less than, now we need the amount we should have spent so far based on the number of months. So our budget amount is that amount in cell B10. And we're going to multiply that by the value in A14. And I'm making this value A14 entirely relative, so it also can drag down from A14 all the way through December in A12, or excuse me, A25. So close parenthesis. So that's our logical test. Now we need a value if that is true. So if it is less than, we want to know how much under budget we are, how much we have remaining to spend. So we need that same amount subtracted by how much we spent so far, the same amount as the test. And we need this to be flexible for the future. So we've got that. It's going to kind of auto-expand to the rest of the range. So that's the value if the first test is true. If it's false, I want it to remind me that I'm over budget and by how much. So I'm going to concatenate over budget. I'm going to do an extra space after the colon so that it will split the number from this label over budget. And then, just in case, I'm going to have it round up. I know I have a formula within a formula here, so I did a double parenthesis. And that B10 value that I need fixed times the month number again, but have that relative, minus the sum of all of the expenditures expanding over time, and I'm going to have it round just to 2 digits. And then close out all the formulas. So it's going to tell me that I'm over budget by $1. I've got $49 to spend. I'm over. Then I've got some money to spend. Then I spent a little extra. And I finally spent a little extra for the year. So these formulas are exactly the same, but Excel thinks that they are different. These are error messages that should be ignored. To clear one of these error messages, I click on the caution message, ignore error. Now you do have to do this multiple times, which is kind of annoying. But it's better than not having Excel check your formulas, even if sometimes Excel is wrong. So there you go. Now I could have had it concatenate under budget, but I think that was kind of obvious in the formula. So we can use all the different mathematical operators to combine with our math, and we can use the technique of pseudocoding, just writing out in plain English what we want to do to help us construct our custom formulas. So thanks again for watching this Excel class. We have more resources on our website. You can click through to lincolnwoodlibrary.org to see everything we offer. You can see what we have going on in our main slider. You can see our events under all events. You can see our catalog by clicking through on catalog. You can search the catalog. For example, we have a lot of books on Microsoft Excel. And you can check one out. This one's currently out, but it'd be a great one to reserve. Go back to the library website. Under Research and Learning Quick Links, you can see all of our premium databases, including lynda.com, which is a great resource that has tons of technology training videos, including on Microsoft Excel. You'll want to create a free account with your library card number and a password, 212420000, and then your 6 unique digits, and create a password. You'll do that under Create a Profile. But while we're here, I can just show you Microsoft Excel. I can show you a preview of what they have. Now, if I want maybe an advanced class, they have 1,270 advanced Microsoft Excel classes. And you can use array functions. I kind of briefly covered that. They've got a whole course, an hour and 26 minutes on array functions. Power user challenges, shorter classes, all sorts of things. So it is a great resource for learning more. And you can use lynda.com with your Lincolnwood Library card. So thanks again for tuning in. We hope you've learned a ton. There are a lot of formulas. You can feel free to pause and play this video by clicking on it or hitting the space bar if you need time. I know that I go kind of quickly, but I wanted to cover a lot so that you can start to become an Excel expert. And Lincolnwood residents with their library cards can also do one-on-one technology appointments where we could cover Excel in even more detail, specific to what you need. We hope you've learned a lot in this video. If you have any questions, let us know. Thanks for watching.